Science can now read your mind. Literally. What if your thoughts weren't private anymore? I don't mean that in some vague, metaphorical way. I mean, what if a machine could literally read your mind? Well, scientists have just cracked it. They've built AI that can translate your brainwaves directly into words and even pictures. This isn't a sci-fi movie plot. It's happening right now. We're going to break down the incredible technology that can decode your thoughts and what it means for all of us. Section 1. The Frontier. For good reason, the human brain has been called the final frontier. This 3-pound universe inside our skulls, with its billions of neurons firing in beautiful, complex patterns, creates everything that we are. Our memories, our feelings, our entire consciousness. The dream of decoding its secret language has kept scientists, philosophers, and storytellers busy for generations. We've all imagined things like telepathy and computers we could control just by thinking. This field, known as brain-computer interfaces, or BCIs, has always promised to build that bridge between our minds and the outside world. But for most of its history, it's been a slow, grinding journey. Early experiments were clunky, often demanding risky brain surgery just to do something simple, like move a cursor on a screen. The brain's code just seemed unbreakable. But now, something has fundamentally changed. The explosion in artificial intelligence has handed us a key, a kind of Rosetta Stone, to finally start unlocking the language of the mind. And the discoveries are coming faster than anyone thought possible. Section 2. The Breakthrough. So, how does this actually work? How do you get from a mess of electrical signals in the brain to a clear sentence or a picture? The secret is a powerful team-up between brain scanning tech and cutting-edge AI. Think of it like this. Your brain is constantly buzzing with electrical activity. Technologies like EEG, which uses a sensor-filled cap to measure brainwaves from your scalp, or fMRI, which tracks blood flow to see which brain areas are active, can record these patterns. For the longest time, these recordings were just noise. We knew something was happening in there, but we had no idea what. This is where deep learning AI, the same kind of tech that powers ChatGPT, steps in. Researchers train these AIs by having someone listen to stories, look at pictures, or just think of sentences, all while recording their brain activity. The AI's job is to find the connection, to match specific brain patterns to specific words, ideas, or images. It's like teaching an AI a new language, but instead of learning French or Spanish, it's learning the unique dialect of your brain. One of the most mind-blowing breakthroughs came from researchers at the University of Texas at Austin, who used a non-invasive fMRI scanner to decode the gist of what people were thinking. In their study, participants listened to hours of podcasts while inside an fMRI machine. An AI system then learned to connect the patterns of their brain activity to the words and meanings in the stories. Later, when a participant listened to a new story or even just imagined telling one, the AI could generate text from the brain scan alone, capturing the essence of their thoughts. It wasn't a perfect word-for-word transcript, but it consistently nailed the gist of the idea. For instance, when a participant heard, "I don't have my driver's license yet," the decoder translated their brain activity into, "She has not even started to learn to drive yet." It got the meaning right. Even more impressive, the system could watch silent movies with the participants and generate a rough description of what was happening on screen, proving it was decoding something deeper than just language. Section 3, the proof. And this isn't just a one-off study. All over the world, Different teams are pushing this technology forward in incredible ways. In Australia, scientists at the Graphene X UTS Human-Centric AI Center developed a system called D-Wave. It uses a simple, non-invasive EEG cap to translate thoughts into text. Participants read text silently while wearing the cap, and the AI translates their brainwaves into sentences on a screen. Currently, its accuracy is around 40% based on a machine translation quality score called BLEU-1, but the researchers are confident they can eventually reach 90%, which would put it on par with the speech recognition software we use every day. Meanwhile, Meta is pouring resources into this field. Their AI research teams have used a sensitive, non-invasive technique called magnetoencephalography, or MEG, to achieve some stunning results. In one study, they were able to decode typed sentences from MEG signals with up to 80% accuracy at the character level. They've also used MEG to reconstruct images people were looking at, with the AI generating a stream of blurry but recognizable images in real time. But maybe the most life-changing use of this tech is for people who can't speak. At UC Berkeley and UCSF, researchers developed a neuroprosthesis for people with paralysis. It does require an invasive implant, a paper-thin array of electrodes on the surface of the brain's speech centers. The AI then decodes the brain signals for intended speech and, in near real time, speaks them through a digital avatar. This has let patients who have been silent for years communicate again, using a voice that can even be trained to sound like their old one. From wearable caps that read your mind to AI that reconstructs movies you're watching, the proof is all around us. We are building machines that can, in a very real way, read our thoughts. Section 4. The implications, promise and peril. The implications here are massive, and they split down two very different paths, one of incredible promise and one of huge risk. Let's start with the good stuff. For millions of people locked in by paralysis, stroke, or diseases like ALS, this technology is a lifeline. It's the hope of talking to loved ones again, of sharing ideas, of simply being heard. Beyond just speech, this could allow people to control advanced prosthetic limbs just by thinking about it. Imagine a person with a bionic arm feeling and moving it as if it were their own. This is already happening in labs. It could change how we all interact with technology. Think about composing an email just by thinking it, or controlling your smart home with your mind. It could open up new avenues for therapy, helping us understand and treat conditions like PTSD by accessing emotional states directly. We might even use it to analyze our dreams, giving us a window into our own subconscious. But for every one of those amazing visions, there's a dark side. This is the peril. The most obvious and terrifying risk is the end of privacy. Our minds have always been the one place we can be truly free. If this tech becomes common, what stops a government from using it for surveillance? Or a company from creating ads so perfectly tailored to your subconscious desires you can't ignore them? As Osaka University researcher Yu Takagi put it, for us, privacy issues are the most important thing. The very idea of mental freedom is on the line. What happens when this is used in court? Could your thoughts be used against you? And what about consent? The UT Austin study found that their decoder didn't work on people who weren't willing participants. In fact, if someone actively resisted by thinking other thoughts, the results became unusable. But as the technology gets better, those safeguards could disappear. Then there's the risk of the AI just getting it wrong. If an AI, with biases from its own training data, misinterprets a thought, the consequences could be catastrophic. This forces us to ask some huge questions. Who owns your brain data? What rights do you have to your own thoughts? These aren't just for philosophers anymore. They are urgent legal and ethical problems we have to solve right now. Section 5. The future. So where is all this headed? Right now, the technology is still young. The most accurate systems still need a bulky fMRI machine or invasive surgery. But the trend is clear. Non-invasive methods like EEG are getting better, and the hardware is getting smaller. Researchers believe the goal of 90% accuracy for non-invasive thought-to-text systems is achievable. We're heading toward a future where thought-to-text is a real thing, where controlling devices with our minds is normal, and where communication is possible for everyone. The line between the human mind and the technology we use is blurring faster than ever. The development of mind-reading AI isn't just one single invention. It's a journey into the core of what makes us human. And it's forcing us to face our biggest hopes and our deepest fears about the future we're all creating together. Conclusion. This is easily one of the most powerful technologies humanity has ever created. It could heal and connect us in ways we can barely fathom, but it also opens the door for control and intrusion on a scale we've never seen. So the real question isn't just what this technology can do, but what we will choose to do with it. What rules do we need to set? How do we get all the amazing benefits while protecting our fundamental right to a private mind? We want to hear what you think. Is this the next great leap forward for humanity? Or is it a step too far? Let us know in the comments below. And if you want to stay on top of the technologies that are shaping our world, make sure to subscribe and ring that notification bell. Thanks for watching.